tibial nerve, which you can see here we've talked about already, and its role in the control of the hamstring. So I did mention to you before that the tibial nerve is responsible for the semitendinosus, the semimembranosus, and the long head of the bicep femoris. The short head, as you can see listed here, is actually picked up. The motor control there is common fibular. Now, today, as we work our way down, so I also mentioned some of these others. The adductor magnus, remember, gets both tibial and obturator, so for adduction. But I wanted today's focus is here in the crural muscles. So the triceps surae, the gastrocnemius, two heads, and the soleus, tibialis posterior, the flexors for the tibial, and the common fibular to pick up the tibialis anterior and the extensors. So think more lateral here. We're talking about the common fibular. Okay, so this is just words, blah, 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 just to get us introduced to what we're going to do. We're really moving into the region of muscles that are distal to the knee. So I have them listed here in the order to try to help you as you're learning in the lab also. The tibialis anterior is the fleshy part on the anterior aspect of the leg. And I would like for you to learn, as I've told you before, the sequence of these muscles. Learn them in sequence so that you can remember them more long term. There's a couple of nuances that I want to point out to you for attachments, where things, you wouldn't be able to understand this, how this muscle works, if you don't understand this attachment. So I'm going to do that with you. But in order across here, the tibialis anterior, then the extensor digitorum longus. This, remember, I pointed out to you before when we were talking about joint movement, dorsiflexion and plantar flexion. Why do they call this muscle extension? So in fact, the muscle is going to promote what we would call in joint action dorsiflexion. It's called an extensor. In fact, that's opposite the way we would probably think. I don't know how you think, but logically I think this is extension, extend at the ankles. That's not the way the anatomist sees this. The angle for extension and flexion apparently is back here, so it's a confusing bit of terminology. So teacher points these things out. Extensor digitorum longus, dorsiflexion. So 1, tibialis anterior, 2, extensor digitorum longus, 3, the extensor hallucis longus. So we're going to pause on that one here in just a moment. I'm going to talk about that a little bit more. Tibialis anterior, extensor digitorum, extensor hallucis. That's the big toe, the hallux. So this muscle has an attachment to the big toe. I'm going to put a couple there, one on the top, one on the bottom. And then for the fibularis tertius, some textbooks call this one the, I'll show you the brevis and the tertius, but in order across the back of the leg, across the lateral aspect of the leg, these are the big four. And then, of course, the gastrocnemius, which we're going to do as a posterior compartment muscle. So 1, 2, 3, 4. Anterior to posterior. There they are. All right, now, for attachments. First, the tibialis anterior. If you feel the front of your leg, it's bone. The front of your leg is bone. It's tibia. So, tibialis anterior makes you think this is on the front of the tibia, and that's true. But the reason I said it that way, the front of your leg is bone, is because I want you to see here clearly that the tibialis anterior is best viewed from a lateral view. The tibialis anterior. It's anterior, yes, but it is also lateral, the tibialis anterior. So we're going to work our way lateral across here. So this guy, that's why it says here, lateral proximal tibia. That's the attachment of the tibialis anterior. And it goes here, again, we won't beat you up with these, cuneiform and metatarsal 1. All right, the second on this image here is to talk about the fibularis tertius and extensor hallucis longus. Okay, but in the order that we did just a moment ago, we had this one second. So if I'm learning from anterior to posterior, the tibialis anterior was first, the extensor digitorum longus was next, in order. Tibialis anterior, extensor digitorum longus. So on this picture, let's do this one next. This one attaches to the lateral tibia and fibula. It's a little more lateral. It's a little more posterior. So working my way from tibialis anterior to extensor digitorum longus, that makes sense. This one over here goes to the 1 side, and this one over here goes to the 2 to 5 side. So I'm just moving the attachments over here. 1, and then 2, 3, 4, 5. I know this is on the metatarsal, but those things you won't remember. Tibialis anterior, extensor digitorum longus. This one's just on the tibia. This one's got to be a little more lateral. It's also attached to the fibula. I'm moving lateral for the next muscle. Okay, the next one, number 3, was the extensor hallucis longus. And so here it is here. Extensor hallucis longus is more posterior and lateral. And you can see I've moved off the tibia altogether now. This one is only on the fibula, as is this one. The fibularis, the extensor hallucis longus, and the fibularis tertius both are located more lateral. Both of them on the fibula. 1, 2, 3, 4, as I work my way across. 1, 2, 3, 4, as I work my way across. All right, so now, so learn the order of the muscles, learn the proximal attachments that will take you across this thing, and the last thing to pay special attention to is these guys all get innervation from the fibular nerve. So if I think about the fibular nerve, this is deep, but it comes off the common. If I think about the common fibular nerve, I'm going to think about the muscles on the lateral compartment, the muscles on the anterior and lateral compartment. This is fibular, and there's an image. Where's that? Don't do that way, don't do that. There's an image that I showed you with that thing shaded in over there, common fibular on this side of the leg. Tibialis anterior, extensors, the peroneus muscles, those are all fibular nerves. And so I've got them listed here, and then now we've looked at them. 1, 2, 3, 4. 1, 2, 3, 4 attachments. Oh, there it is right there. I put it right there. So lateral. So common fibular. There's your lateral. And this says the superficial branch, and the deep branch, of course, is the one that picks up a lot of these muscle fibers. So, all right. So I have here, in years past, I've compared these attachments to the arm muscles. You're learning them, so I'm going to skip that for today. All right. Now, I'm going to shift gears now. You can see that these muscles here can be viewed, these fibularis longus and fibularis brevis muscles can be viewed from the lateral view. So if I'm labeling these things from anterior to posterior, these two muscles are in that view. But the reason I've pointed them out to you here, the fibularis longus and brevis, is so that I can talk a little bit more detail about their attachments. These muscles that have fibularis in their names are oftentimes referred to as peroneal muscles. And they are odd. This one is odd. The first one is odd. I wanted to take a moment to talk about it because it doesn't do what you would expect it to do. So normally, when I think about general description about what happens at my ankle, I think as I move my ankle this way, dorsiflexion, I memorize those 4 in sequence with an extensor in the name, and I say to myself, that is lateral compartment of the leg, and that is fibular. Fibular's on the lateral side, and it does dorsiflexion. I know femoral does extension at the knee. I know the sciatic and the tibial here on the back, with the hamstrings, and that does flexion at the knee. I can do dorsiflexion at the ankle with fibular. Tibial is going to do plantar flexion. Okay, but there are some exceptions to that rule, and this one is bizarre. So that's why I just pause here for a moment. This is the fibularis longus and the brevis, but the longus is the really weird one. So the fibularis longus here, or the peroneus longus as it's sometimes called, is attached to the head of the fibula. It's attached from the proximal side of the fibula. It's a lateral muscle. So I would think, if I'm learning general descriptions, I'm thinking this thing is innervated by the fibular. Would you be right about that? Yeah. Okay, so that makes sense. It's good. No problem here. And when I think about the fibular nerve, I think dorsiflexion. You see the problem here? This one does not dorsiflex. Look at the attachment of this guy. From the proximal fibula here, it attaches to the first metatarsal and the medial cuneiform. Now we had other muscles here. Remember when we looked at this before? The tibialis anterior was on the medial cuneiform, and it did dorsiflexion. Now we're going to put a muscle attachment on the medial cuneiform and the first metatarsal, and we're going to do plantar flexion. Now, how is that possible to have a muscle attached near the knee and going to the medial cuneiform and first metatarsal and doing dorsiflexion, and another muscle just a little bit posterior to it with very similar attachments? Instead of being on the tibia, it's on the fibula, but the distal attachment's the same. And it does plantar flexion. How is that possible? And so this picture illustrates that for you, what happens to the tendon of this guy. The tendon of this muscle actually passes along the lateral border of the calcaneus and then ducts inferior to the cuboid to attach to the cuneiform, the medial cuneiform and first metatarsal here, on the bottom of the foot. So it's lateral there, but as it crosses the calcaneus, it goes underneath. So the distal attachments here, as you can see, the fibularis longus, the distal attachments are the first metatarsal and the medial cuneiform. The distal attachments of the tibialis anterior are the first metatarsal. So do they attach at the same place? One of them does plantar flexion and the other one does dorsiflexion. The tibialis anterior gets fibular and it does this to your ankle, whereas the fibularis longus does this. And it's because of this weird traversing of the tendon of the fibularis longus. It is in fact an unusual situation. It is fair to say plantar flexion is tibial, dorsiflexion is fibular, except for these guys. This one in particular, the one I'm emphasizing to you, the fibularis or peroneus longus. It gets fibular. It's where the fibula goes. But it does the opposite because of this odd attachment. And this one also, it's not quite as dramatic, but it's brevis. It's a shorter one. You see it doesn't go all the way up the fibula here. So the fibularis brevis also has its attachment out here lateral. So it does do some plantar flexion. But this is the weird one. So pay attention to that. Point out the things that are odd. All right. I did that. Now, here's the back. This is plantar flexion, and these guys get tibial. So the first one here, the big one, is the gastrocnemius. And this one has attachments on the medial and lateral condyles of the femur, and then it has its attachment down here to the calcaneal bone. The tendon of the gastrocnemius is what we would have called today, most people refer to this tendon as the Achilles. And as you remember on my slide before, we called the gastrocnemius and its counterpart, the soleus muscle, the triceps. So let's look at that again and then I'll show it to you. So here it was on the original picture. We said this tibial nerve, did I say that on here? Yes, I did. Good. So this tibial nerve gets triceps surae. That's what that stands for right there. Tibialis posterior, the flexors. So these are posterior muscles of the leg that do plantar flexion, or flexor muscles. The triceps surae is three muscles, the two heads of the gastrocnemius and the soleus. All right, so let's look at them. Here they are. The gastrocnemius first, the femoral condyles and the calcaneus. All right, now, just deep to the gastrocnemius, so I have, you can see the gastrocnemius now has been cut. There's the medial head and the lateral head. There's that popliteus muscle that I mentioned to you that unlocks the knee. And you can see this muscle deep here to the gastrocnemius, the soleus, which has both tibial and fibular connections and the interosseous membrane. The real take-home message here for this guy is it's part of what we would refer to as the triceps of the lower leg. It shares the attachment of the gastrocnemius on the calcaneal bone. The soleus muscle, two heads of the gastrocnemius and the soleus. The triceps surae. The plantar flexors, they get tibial innervation. Now the plantaris muscle, if you remember, the plantaris muscle that you saw in the laboratory, you learned it. I tried to make an issue out of it for you guys in the lab. I tried to make an issue out of the plantaris muscle in the lab because students confuse it with the soleus. So when you're looking in the laboratory at your cat gastrocnemius muscle and soleus muscle, sometimes you will confuse these, trying to figure out which one is the plantaris, which one is the soleus. And your lab manual describes it like this. It says, this muscle fuses to the lateral head of the gastrocnemius. And so that's the way I taught you to try to remember its attachment, to find it whenever you're looking for it in the laboratory. Now, in humans, it's not that difficult because the muscle fibers of the plantaris run out really early. You can see the plantaris here attaches along with the lateral head of the gastrocnemius to the lateral condyle, the femur, but then it becomes a tendinous strip. Just as it gets to the inferior portion, inferior margin of the popliteal fossa, it's just a band, this plantaris muscle is. And you can see it attaches to the calcaneus. So how many muscles really are attached to the calcaneus? Everybody learns the tricep, two big heads, the gastrocnemius and the soleus. But the truth is the plantaris goes there also. But we don't normally think about the plantaris as a major flexor. The triceps are major plantar flexor muscles here, the triceps, so that's okay. And this shows the tendon of the plantaris here running alongside the calcaneal tendon to attach to the calcaneus. All right, soleus and plantaris. Last bit, this is it. So here are the deeper muscles that you're supposed to find in the laboratory. The tibialis posterior here, you can see they all get tibial. The foot attachments shown here are all on the bottom of the foot. And so this tibialis posterior had a clue in the laboratory. Do you remember what it said about this muscle? So I can find the tibialis anterior is on the anterior side of the tibia, but it's really lateral, right? There's nothing on the front of your leg, that's bone. Okay, if I look on the back of the tibia, I find the tibialis posterior. I recognize its name, it's got to be on the back of the bone. But what was the clue in the laboratory for finding it? Remember?
Was it the shiny?
Yeah, it had that thick, shiny tendon that was running right along the distal edge of the posterior. You can see the exact same thing in a cadaver here. There's that shiny tendon there of the tibialis posterior. It does have both tibial and fibular attachments, the tibialis posterior, and then to the metatarsals. The next one, the flexor digitorum longus. Attachments here to the posterior tibia and to the phalanges, plantar flexion, tibial innervation. And the last one to the big toe, the flexor hallucis longus, and this one goes from the fibular shaft to the big toe. So, plantar flexion, tibialis posterior, flexor digitorum longus, flexor hallucis longus. Are these the only muscles that flex? No. There is a pair, right? A pair of muscles that does plantar flexion that gets fibular. Those are the weird ones. But these make perfect sense for their attachments. All right. Now I will entertain your questions for the second exam of the semester.